So it's great to be here. It's a hard act to follow after Steve talking about autonomous vehicles, but it's the next big thing, like Samsung likes to say. But it's one of those things that's on the horizon, and I'm going to talk to you a little bit about connected vehicles. What I'll talk a lot about is this pilot program we're launching, because we're spending a lot of time trying to educate people across the country about what we want to try to accomplish in these pilots. But before I get into that, I think I better set the stage a little bit more, because while your TxDOT director and deputy and Dennis Christensen talked about connected vehicles, how many people in the room know about connected vehicles? Okay, a little more than half. So connected vehicle is basically about putting communications into your vehicle. Think about it like Wi-Fi from your internet. From your computer. You could kind of think about as your cell phone. That is one option, but a lot of what we're talking about is something called dedicated short-range communication. So this is wireless communication that's happening in a 300-meter range, sending data, speed, braking, heading, critical basic safety information 10 times a second. This information is sent from every vehicle. And so it's sent around that immediate radius. It's sent in an open standard. It's sent securely. And other vehicles will listen to that information and then be able to do various different things from that. And the infrastructure, depending on what's placed out, will do interesting things. So if I paint a scenario, today, if you have a collision warning system on your car, a suite of radar cameras and sensors, and you can see the vehicle right in front of you. Well, let's imagine there's a large truck right in front of you and 3 cars in front of that, and they slam on, that first car slams on your brake. You don't see it until the truck brakes. With connected vehicle technology, as soon as that first car brakes, you're getting a warning. You don't have to wait until you've run into the back of the truck. Okay, so you're on a 2-lane rural Texas road. You're thinking about passing the person in front of you and going around, common kind of thing. There's a vehicle coming at you at high speed, and you can't really judge their rate. You're not sure. This technology can be used to tell you, wait, you turn the turn signal on, you're about to go over, they give you a warning, stay put. You're not going to make it around that vehicle in front of you. So it's this kind of safety technology at an intersection in an urban area. You're trying to make a left turn across traffic, and you can't judge the speed the oncoming traffic is coming on. So we worked over the last few years to conduct a safety pilot in Ann Arbor, Michigan, where we focus on a couple of these critical safety applications. To gather data, we had 3,000 vehicles. 60 of them had fully integrated warning systems, about 2,500 of them, trucks, buses, and everyday drivers, their vehicles. We put on kits, basically, that were just the communications devices sending out signals. And so we operated it for a year to determine and see, will there enough vehicle interactions, do they not run into each other, but communicate with each other enough, and would these kind of accidents be prevented? And through that test, through other research we've done with the auto industry on a pre-competitive basis, we gathered data, and then in February, NHTSA decided that they and the Secretary announced that NHTSA was going to pursue regulation related to this technology. They said they'd do it by the end of this administration. Then in August, NHTSA issued an advance notice of proposed rulemaking. So they have started the rulemaking process. So they basically, with that, in some model year out in the future, probably 2017-18, they would, when the rule gets into place, 2016-17, some model year future, say 3 years from that, all vehicles coming off of the assembly line will have connected vehicle technology. So that is the path we're headed down. So if you have to buy a new car, buy it now, wait 3 years, I don't know, different technology will always be coming. We're not trying to replace the radars and the sensors and the navigation systems you have, we're trying to build from it. Just like Steve said, that'll then lead into more effective automated vehicles in the future as well. And so we gathered and did this safety pilot, but that's great. That's vehicle to vehicle. That is working towards saving 35,000 lives a year. But there's all kinds of operations issues. There's all kinds of traffic management. There's transit management. There's incident response. There's all these other applications that community says, I would love to be able to communicate with travelers right away. I'd like to be able to communicate with them in the next 1 to 2 minutes saying, take a different route, an object just fell off the back of a truck, be prepared to stop in a 500 feet or something. There's all these different applications, but in the U.S. Department of Transportation, we've been working with the community to develop some of these applications, but we now need to operationally test and demonstrate them. So the rest of this presentation is really going to talk about this program, talk about what we're trying to do. We're really trying to educate the community so that we get the best proposals possible so we can spend our money wisely, gather benefits information, and help people like TxDOT understand how to implement, what to implement. We need this to be nationally interoperable. We cannot have TxTag and EasyPass and SmartPass. This has to be nationally interoperable. So it's a major effort. It's going to take a lot of work, everyone working together to do this. And so I want to take a few minutes to talk to you about what we're trying to do in the pilot program. So we're trying to spur early deployment. That's the first thing. We've been working a lot on the standards, the specifications for equipment, for communications, both in vehicle and at the roadside. And so we want to spur early deployment of the infrastructure, the mobile devices, and vehicle technology. Second, we need benefits information. It's great that John Barton and Dennis were up there talking about connected vehicles. You can't tell me that any of your operational offices are going to implement and say, I want to spend it until they see the benefits. You need to know that it's going to help improve your operations, it's going to improve your safety issue, it's going to improve the environment. So we're going to put this program in place to get that benefit information that we know you all need. Lastly, we're going to help to resolve deployment issues. Our pilot program is really focused on solving issues. We want agencies to put together a suite of applications that will solve their problems. This is not technology looking to solve any problem. There are specific problems, different kinds of scenarios, different sorts of implementations can solve, and we want to do that. So let me talk a little bit about the organizing principles and what we're trying to do. The pilot deployments are going to be real world. We would like these to be early implementations. We would like this equipment to stay in place and be used by implementers for the next 20 years. Yes, they'll probably need some software upgrades. Yes, technology will change. Yes, they're an early implementer. There's some risk. But our intent is, and we think we're at the stage where this technology can be implemented and used. We're going to have multiple pilot sites. We are not trying to do just one site. We are trying to do many. We are situating this program to do one solicitation in early in January, and then a couple years from now do another solicitation. So we can build from what we learned in the first one, but do more. But have several different pilot deployment sites solving real problems today in a meaningful way. And they're supposed to be large scale and multimodal. Now, large scale doesn't mean it has to cover all of Dallas-Fort Worth or all of Texas as a whole, but that it's large enough that you can gather meaningful benefits information. You can do an evaluation and you can understand, was there a benefit, was there an impact from this deployment project? So a couple of the requirements. We're going to require that there needs to be several different applications bundled together in these different pilots. A lot of this information, it's about data sharing. It's about generating data, generating information, and then using that. It's a big data problem, and it's a big data solution. And so the technology and the vehicles interacting, providing data, need to be used and pulled together so you could do a signals application with a traveler information application, with a snowplow application, and I'll talk more about that as we go. We have funded over the last 3 to 5 years several $100 million worth of research in connected vehicles. And a lot of that has been on the V2V safety, but a lot of that has been on other applications. So these pilots need to include some of those applications, but we know you're a lot of smart people out there, and you have ideas of how this technology could help you. We encourage you to consider putting those in the mix and adding that to the suite of applications that are considered for deployment and testing. And we want to capture data from multiple sources. So while we talk a lot about DSRC and we talk a lot about that communication, your cell phone, your NAS system, there's other equipment that have some of these capabilities that you can use and we can try to test. So I talk about multiple communications. This just summarized that. DSRC and the basic safety message is sort of a critical component to connected vehicles. One of the things that I didn't mention before, and it kind of ties with what Steve said about security. So one of the big differences in connected vehicle and versus automotive technology today, in connected vehicle world, your Toyota has to talk to your Ford, has to talk to your GM, has to talk to your BMW, and you have to trust the data coming from that other vehicle. It has to be secure, it has to be private, you have to trust it because you're going to make control actions and warning. And so that's a critical part of what DSRC provides, and that's a critical part of what connected vehicles is trying to enable. We really want you to think about what problem you have. So as a result, what is your performance metric? What is your measure you're trying to understand and solve? We need you to share the data and the lessons learned with folks when we do the results. But when you're doing the tests, I mean, this is private data. You have equipment in vehicles. We're not trying to track drivers. That is not what the program is about. They're sending out information. We don't know who it is. We don't know what vehicle it is. We're trying to provide safety around that vehicle, and we're trying to provide data into operations centers to make better operational choices. And I talked a little bit about security and credentialing. There's a large system that will need to be put in place. Think about your credit cards. Think about the data you want to send securely, and maybe that was a bad example these days, but we need security. You need to trust the information. There has not been a security system that runs in real time at this level ever. That is our major technology hurdle that we are in the middle of sort of the final step, and finding someone that wants to operate it. So we expect folks to bring a partnership together. This is going to take the state. It's going to take the city. It's going to take freight operators. It's going to take the automotive sector, private system integrators, research institutions. Bring the team together that can help you pull this together. It's going to be a several-year program. We think they'll take about a year, 6 to 9 months, to really, from proposal and award, to give you some more time to think about your concept. Write it down. Get the concept of operations, follow the system engineering process, write requirements, really make sure you can implement this. Then a year to really deploy everything, whether that's technology, backhaul communications, control systems, bringing together equipment to put in vehicles to generate data, all of that package of information, and then an 18-month demonstration and testing phase. So now let me talk about the applications and kind of really take some more time to explain how connected vehicle technology can be used and can be packaged. And so USDOT, we work with all our stakeholders, a lot of the state DOTs, the cities, to determine what kind of applications make sense, what were their issues. And over the last 10 years, we've been working on various different applications. And we have concepts of operations, we have requirements documents, we have prototype testing, we have designs, all that information. We've done some modeling and simulation to get benefits. We're in the process of putting that all on the website. A lot of it's there, and so there's a lot of detail already available. And so we intend to have people use that. But one challenge is we are still building these applications. They're still prototype. We're doing them in open source for the most part. By the end of this year, they should all have documentation on the website. Some of it is more detailed than others, which is why we say you should use some of them, not all of them. But there's a lot of applications to choose from that I think you'll find to be meaningful. So this is probably you might be able to read it in the background. These are all the applications we've been working on, and we group them in various different ways. We have vehicle to infrastructure safety. So think of these as red light warning, curve speed warning, spot weather impacts, pedestrians in a signalized intersection. You're trying to provide warnings from an intersection to vehicles. Vehicle-to-vehicle safety is what the safety pilot did, and that has a lot of different emergency brake lighting, forward collision warning. There's a bunch of applications on agency data, core and center to operations, and what this group in the audience here is focused on, looking at traffic monitoring, turning movements, intersection analysis, maintenance type things. There's a whole bunch of applications related to the environment. Think of an eco-traffic signal. You're trying to send information to a vehicle that would, as you're approaching a red light, Maybe you slow down as you're approaching so you're not idling as long. Or you have a green light and now all of a sudden you know it's still going to be green for another 15 seconds so you can keep driving through. Or you get to the intersection and the car knows to turn the car off because it's going to be sitting there for 2 minutes and the engine's smart enough to not sit there and idle. So these are the kinds of applications the auto industry and the public sector is working on. Road weather applications, a bunch of mobility applications around advanced signals, advanced highway operations, speed harmonization and speed warning type applications. If you have blind curves, think of putting an intersection warning out for that kind of thing. And then smart roadside. So we talk a lot about freight, and I-35 is a major freight corridor. How do you do wireless inspection and smart parking with connected vehicle technology? So let's talk about what we want the sites to do as they're thinking about how to pull an application together and how to put a pilot together. A lot of it, we really want people to start with what are your needs, what are your problems, how do you think connected vehicle is going to help you. Set performance metrics, and then select the applications that are going to work to help you meet these goals. And so now what I want to do is run through a few scenarios. These are not scenarios we expect to be repeated back to us in proposals, but are scenarios to help provide a message and give you some information. And I'll try to liven it up a little bit, and we'll test my Texas geography while we do it. So let's talk about downtown Austin. Okay, and so you want to improve congestion and do arterial network information. And we're kind of green in Austin, I think. At least they want to be, our UT friends. And so we really want a lot of eco-traffic signal applications. And so you're going to look at downtown Austin. We're going to look at 6th Street, and we're going to say, we want to put some advanced signal operations there. We're really worried about the pedestrians walking around at evening. We're really worried after they lose that football game, them walking around safely. And so we're going to design our system to combine public transit and look about how we take our public transit applications, connect them up with those passengers that are waiting on the roadside who claim they want a route, they want a ride. How do we provide information to that transit vehicle about the number of passengers waiting or the number of spaces available on that vehicle? How do we know that it's trying to connect into that light rail line? And so we'd like the light rail that just stopped to know that there's a bus coming, and we'd like to hold the train so we can get all those bus passengers. We'd like to look at eco-signal applications so we can have the drivers not idling downtown and be able to advance through that intersection. And then pedestrian safety warning. So that's a package of types of applications that would make sense in an arterial, dense urban network. All right, so let's talk a little bit about downtown Dallas and US 75, and we're trying to get traffic inside and outside of Dallas, and there's a major incident that's happened. And so we have our ICM system. I'll segue to the next thing, but we really want to communicate to vehicles about the incident, and we want to look at communicating with our first responders around that incident and provide incident management and incident staging. But we're going to set up a portable work zone or incident staging clearing, and we're going to send out connected vehicle safety messages so that vehicles approaching that incident situation will know to slow down, maybe move over a lane, do different things to clear and get around that incident. We also know that 5 miles up, instead of putting rows and rows of variable message signs across the highway, we're going to use connected vehicle technology and put in-vehicle messages into every vehicle to say, instead of driving 65, drive 50. That's 3 miles out. 2 miles out, drive 40. And then last couple miles in, drive 20 and maybe use the left 2 lanes. And so we can do speed harmonization, we can do queue warning type applications to help manage traffic flow. And lastly, we'll do a lot of traveler information to say you could use US 75, but you could take an alternate route, or you could move over to transit, and you could get to your destination in a timely manner. So this is one way of how to pull together some connected vehicle in an urban expressway. So now let's talk a little bit about a rural area. So we'll talk out in West Texas, and you have a lot of, we heard this morning about all the snowstorms and major incidents and issues. And so we really want to look at how you handle weather responsive traffic management, how you handle those weather situations and provide information. But we also have a safety issue at the few traffic lights we have and the stop signs, because there's a lot of rural intersections with stop signs, and we want to provide travelers with warnings related to how their vehicles can enter into that rural roadway without when they're having a hard time seeing down the roadway to see the vehicles coming. But we also have a rural population that needs some dynamic transit operations. They need to get to their medical appointments, or they need to get to their job, and so they could have some dynamic transit routing options in which you could use this technology. So still out there in West Texas, because it doesn't snow anywhere else. I mean, the ice is, but you know. So we need to look at work zone, maintenance decision support systems, and pavement monitoring. And so you could use this technology. Think about a vehicle that drives over all those non-existent potholes, and but the accelerometer changes. And so now you know there could likely be a pothole, and you'll know the exact location of that pothole. So think of that information coming to the maintenance center and having how that could help you understand. Think about driving down the road and it's below 30 degrees and windshield wipers are on. So you're thinking, okay, it's snowing now. I better send out my maintenance workers and I need to salt this road. I need to treat the other road, but it's not snowing in this other sector yet, so I can focus over here. So there's a lot of real-time data that can be sent around to help maintenance, help weather response in work zone situations. I think this is about the last example we have. If we think about freight and goods movement, there's a lot of benefit we can get from having real-time information about freight, having information to optimize routes so we don't have empty trailers driving around, and so drayage optimization, and then getting trucks into and out of their port or inland port or warehouse, and how we do that. Truck safety applications, looking at those high-speed curves, and warning and lane change information so that vehicles traveling behind large trucks that can't see have some safety applications that they can be using to help prevent safety situations. So a couple slides, one on the schedule. That should whet your appetite a little bit about what we're trying to accomplish. We hope to have a solicitation. Well, right now we're doing we're doing several webinars. We're doing presentations where we're asked. So like today, I'm out here. Last week, one of my colleagues was in California. There's a lot of interest across the country in this, and so we're trying to get the word out. We hope to have a solicitation out in January, hopefully out for at least 60 days, make awards by September, and then run this test, and then we hope to do it all again in 2017. And so that's the high-level schedule. There's a lot of information on our website, in which we have here. One of the things, if you like some of those discussions about those different scenarios, we've actually videotaped several of my USDOT colleagues who are more experts in some of those different areas, and so you can watch some webinars and you can watch some videos having them talk about these different applications. We have the concepts of operations. We have all the documentation related to the program on this page. I'd really encourage you to look at this to get better information about connected vehicles as a whole and what we're trying to accomplish with the pilot program.